Hello, welcome to the fifth part of the second module of Mech. In our last classes, we have deduced that the equation for entropy is S equal to K ln omega. Now, if we apply that equation in the case of ideal gas, then what we are going to get is given in the screen, right? This was the equation. Okay. Now, looking at the equation, we may think that entropy S actually depends upon N and V, right? So it has to be an extensive parameter. What is an extensive parameter? Extensive parameter, right? Extensive parameter actually depends upon the size of the system, which is N, that is proportional to N and V, which exactly is this equation, right? But however, this equation as it is not an extensive equation. Okay, because mathematically, if you increase the size of a system by a factor of alpha, then entropy should also increase by a factor alpha, right? Now that means if you increase the size of a system by a factor alpha, if that parameter is extensive, then if entropy is extensive, then entropy should also increase by a factor alpha. However, if you look at this equation, in this equation you have n and logarithm of v, right? If you got an equation with logarithm, this type of linear equivalence will not work, right? So because of the existence of ln v, this equation doesn't change by a factor alpha even if the size of the system increases by an amount alpha, right? Now that is a problem. Okay, this is a very serious problem to be dealt with, because what it means is the total entropy of a system is not equal to summation of the entropy of its parts. അതായത് സിസ്റ്റത്തിന്റെ ടോട്ടൽ എൻട്രോപ്പി എന്ന് പറയുന്നത് സിസ്റ്റത്തിന്റെ ഉള്ളിലുള്ള എല്ലാ സബ് പാർട്ടുകളുടെയും എൻട്രോപ്പി ആഡ് ചെയ്താൽ കിട്ടില്ല എന്നുള്ളൊരു അവസ്ഥ വരും. മനസ്സിലാവുന്നുണ്ടോ? ബിക്കോസ് ഈ ഇക്വേഷൻ പെർഫെക്റ്റ് അല്ല. Okay, so we have to modify this, and we have to see a logical problem, which is called Gibbs paradox, and let us see that in detail. Now let us deal with the entropy in details, the Gibbs paradox in details. So you got this equation, right? Now for the simplicity you need to rearrange this equation. Okay, so what I'm going to do is I'm just changing E1 with its equation, which is 3 by 2 n1 kt, right? And I'm just taking out V1 from this equation. So this is a logarithmic equation, so you know how it works. So n1k ln V1, then rest of the term will be this one. Here you will have 3 by 2. This 3 by 2 is this one. 3 by 2 will come here. N1k is here, then rest of the term will be here, right? Simple multiplication, you can sort it out, and the last term is written as it is. Now from this equation you can see that this term 3 by 2 n1k and 3 by 2 n1k is common, so you can take that as common factor and write it in this form, right? So that is what we are going to do as a first step. So if the equation for S in general is this one, this is S1. So you can just replace N1 with N2, so then you'll get equation for S2, right? and V with V2. Now these are the individual equations for entropy. Now consider both systems are mixed. Okay, this wall is taken outside or is um, what? Yeah, taken outside. Then what will be the entropy of mixing, right? So now you got a one complete compartment, compartment with total volume V and a total number n1 plus n2 that is equal to n, right? V is what? V1 plus V2. Pretty obvious, right? So our equation will be what? It would be similar to this one. So instead of n1, what you have is capital N. K is constant, so K is itself K. And instead of V1, what you have is ln V, right? So this is what written here. Mm. N is nothing but n1 plus n2. That is just a number, right? Number of particles. So n1, v1 plus 2 will be v, right? That would be the first part. Second part is individual equations. So because you got mass here, right? So mass of particles in the first chamber and the second chamber may be different, so you cannot just add these things here. Okay, so I need to find out individual equations, which is 3 by 2 n1k into this term just like this, and 3 by 2 n2k into rest of the term, right? So this is the entropy after mixing. Okay, now let us calculate the increase in entropy, which is called entropy of mixing. So for that, what you have to do is you have to subtract the entropy, the individual entropies from entropy of the system, which has been already deduced, right? You have to subtract S1 plus S2 for two compartment systems. If you have n compartment system, then you have to add it n times, right? S1 plus S2 plus S3 till Sn, right? From the entropy of the system, right? Which is St. So that is what we are going to do. And you can see that logarithmic terms will get subtracted, and our equation will become pretty simple. And you can just rewrite those equations. You can take n1 terms and n2 terms uh, into one part, right? So so first term will be this one, right? Because this is logarithmic term, and you have n1k ln v1 plus v2 minus n1k ln v1, right? So this will be together like this because of the property of how logarithm works, and this will be like this, right? Which is pretty obvious. Now the most important thing from this equation is delta S is positive, which is as expected, right? Entropy change has to be positive, and that is what we learned from the second law of thermodynamics, right? Now especially this comes when we are dealing with a reversible process of mixing, right? That is very important. It is not reversible. In reversible process, entropy change has to be zero. So this is irreversible. So pretty obvious is that delta S is positive, right? Now let us consider a special case where the number density is same, right? Number density is same means total number of particles divided by or number of particles divided by volume is the same, right? In that case, in that special case, number density equal to n1 v1 has to be same with n2 v2. So in the composite system, n1 plus n2 have to be when divided with v1 plus v2 has to be this same constant, right? because you're dealing with um, a system where your number density is the same, right? So the thing is, from this equation, you can pluck out v and insert n directly to the equation for this case. That's what we are going to do. You just replace v1 with n1 by n from this equation, right? N2 by n with v2, right? Like that, you do it for both terms, and what you are going to get is a simpler equation in terms of n, right? There is no v here in this special case, right? That was our aim. Okay, and now we are going to Gibbs paradox very soon. So you have this equation where change in entropy is all in terms of n, right? N1 k ln n1 plus n2 by n1 plus n2 k ln n1 plus n2 by n2, like that. Okay, so till now it's all very comforting because delta s has to be a positive for irreversible process, right? Now, what happens for a reversible process, right? That's where the paradox come. Okay. Now, what I'm going to do is I'm going to check what happens when earlier these two gases were dissimilar gases, right? Because you got an irreversible mixing, right? Now, in new case, in this case where particle in both compartments are the same, right? Then you have a reversible process, right? Because let us have this compartment, right? Now here also you have same type of gas, here also you have same type of gas, right? And if you take out this wall, these two gases will mix, right? Then after some time, if I put this wall back, you can actually recreate the earlier situation, right? So same number of particles will be here and same number of particles will be here, right? So in the case of same gases, change in entropy has to be zero, right? The change in entropy has to be zero. Now if that is not the case, the entropy will uh, എന്താ പറയുക ഇപ്പം നമ്മൾ ആദ്യം എടുത്ത ഗ്യാസ് എന്ന് പറയുന്നത് പണ്ടെപ്പോഴോ ഒരുപാട് തവണ മിക്സ് ചെയ്ത് അതിൻ്റെ എൻട്രോപ്പി മാറി 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 വരണമായിരുന്നു, ശരിയല്ലേ? സോ നമ്മൾ ഏത് ഗ്യാസ് എടുക്കുകയാണെങ്കിലും അത് പണ്ട് എവിടേക്കോ മിക്സ് ചെയ്തിട്ടില്ലേ, അപ്പോഴൊക്കെ അതിൻ്റെ എൻട്രോപ്പി മാറേണ്ട ഒരു അവസ്ഥ വരും, റൈറ്റ്? സോ സാധാരണ കേസിൽ സെയിം ടൈപ്പ് ഓഫ് പാർട്ടിക്കിൾ ആണെങ്കിൽ നിങ്ങൾ സെയിം വോളിയത്തിൽ കൊണ്ടുപോയി വെച്ചിട്ടുണ്ടെങ്കിൽ ഇറ്റ് വുഡ് ബി ഓൾമോസ്റ്റ് ഓൾ ദ ടൈം സെയിം, റൈറ്റ്? സോ in the case of particles in the case of same particles in both compartments, that means reversible process, entropy has to be, the change in entropy has to be zero. But what we get from this equation is not that case. In with this equation we are not getting a change in entropy as zero. What we are getting is a positive quantity, which has to be wrong. Can be proved very easily. Okay, this can be proved very easily. Now you are dealing with same samples, same gas samples, right? You're dealing with same gas samples in both compartments, right? Compartments. അങ്ങനെയാണെങ്കിൽ you can write S1 like this. Only difference is instead of M1 you will have M. Okay, എന്താ കാരണം? Because M1 and M2 are same. അപ്പം ഇവിടെ M1ഉം M2ഉം മാത്രമേ മാറ്റം ഉണ്ടാവൂ അല്ലേ? ഇൻസ്റ്റെഡ് ഓഫ് ദാറ്റ് it will be M. So you can eventually reach this equation just like the way we proceeded in the earlier case. Our equation will be this one, right? Our equation will be this one, which is same equation as a reversible process, and this is positive instead of instead of 0. Okay, so that is where the paradox comes, and this paradox is called Gibbs paradox of entropy mixing. Gibbs paradox. ഓക്കെ, ഒന്നും കൂടി പറയുകയാണെങ്കിൽ ആദ്യത്തെ കേസിൽ ഇറിവേഴ്സിബിൾ പ്രോസസ് ആയിരുന്നു. വി ഗോട്ട് ടു ഡിഫറെൻറ്റ് ഗ്യാസസ്. അപ്പോഴാണ് ഇറിവേഴ്സിബിൾ പ്രോസസ് ഓഫ് മിക്സിങ് വരിക. Now you have deduced an equation from there, and now you are changing the equation for same sample of gases, right? But the only difference is for same sample of gas, the process is reversible. That means change in entropy has to be 0. Okay, so change in entropy is 0 for reversible process. However, from the equation you are getting a positive quantity. So this is called Gibbs paradox, and this is a sure question for your examination. Okay, so define Gibbs paradox and how it is rectified is a very crucial question for your Kannur University examination, and these equations will come every now and then in UGC CSIR net also. So this equation has to be by hearted if you want to do it very quickly. Otherwise you can just deduce it like this. Okay, അത് എങ്ങനെയാണ് ഈ പാരഡോക്സ് നമുക്ക് സോൾവ് ചെയ്യാൻ കഴിയാന്നുള്ളതാണ്. സോ ഇൻ ദ ഫസ്റ്റ് പ്ലേസ് ദ പാരഡോക്സ് കം because of that term LNV, right? That was we discussed earlier about the extensive properties, right? Because of logarithmic value of v in the equation, s in that equation is not extensive, right? So that's what we have illustrated through the Gibbs paradox. നമ്മൾ ആദ്യം തന്നെ പറഞ്ഞ എന്തുകൊണ്ട് എസ് എക്സ്റ്റെൻസീവ് പ്രോപ്പർട്ടീസ് അല്ല എന്ന് പറഞ്ഞുകൊണ്ടാണ് നമ്മൾ തുടങ്ങിയത്. സോ ഇറ്റ്സ് an illustration of that Gibbs paradox. Gibbs paradox is an illustration of that. Now the question is how this paradox can be get rid with, right? How this can be solved. അതാണ് we are going to do now, right? For that, let us consider a simple what I can say equation, right? Now what this equation means, let's say you have an equation log n plus n1 plus n2 factorial minus log n1 factorial minus log n2 factorial. So if you have a factorial logarithm or logarithm factorial of a number, then you have to use the Stirling formula, right? Stirling formula, which is ln n factorial is n ln n, ln n factorial is equal to n ln n minus n, right? This we already discussed in our last class. So Stirling formula is you want me to rewrite this, then I'll rewrite here. Stirling formula, ln n factorial equal to n ln n minus n, right? So you can just expand this term n1 plus n1, n1 plus n2, ln n1 plus n2 minus n1 plus n2, that is equal to minus n1 minus n2 because of this minus, right? Now ln n1 is what? n1 l1 l n1 ln n1 minus n1, that is what written here, n1 ln n1 minus is what? Plus. right? uh, Again minus ln n2 factorial, which is n2 ln n2 minus n2, which is plus n2. So n1, this thing will get cancelled, right? Now if you want, you can write this, right? You can write like this is n1 plus n2, right? And this n1 and n2 can get cancelled, right? And our equation will become n1 l1 n1 logarithm of n1 plus n2 by n1 plus n2 logarithm of n1 plus n2 by n2. So do you remember this equation? This equation is the equation for entropy of mixing, right? This one. Mm. So I can write entropy of mixing as in terms of factorial, which is k ln n1 plus n2 factorial minus ln n1 factorial minus ln n2 factorial. ശരിയല്ലേ? അപ്പോഴാണ് നമുക്ക് മനസ്സിലായത് നമുക്ക് 0 ആണ് കിട്ടേണ്ടത്. Instead we are getting this quantity. ശരിയല്ലേ? Instead of 0 for reversible cases. Reversible case. ശരിയല്ലേ? അപ്പോൾ അങ്ങനെ കിട്ടാൻ പാടില്ല. അങ്ങനെ കിട്ടുകയാണെങ്കിൽ തന്നെ നമ്മൾ എന്താ ചെയ്യുക? ഇപ്പം നമ്മൾ പറയാണ് നമ്മളുടെ എൻട്രോപ്പിയുടെ ഒറിജിനൽ ഇക്വേഷനിൽ മിക്സിങ്ങിൻ്റെ ഇക്വേഷനിൽ ഒരു മൈനസ് കെ എൽ എൻ എൻ വൺ പ്ലസ് എൻ ടു ഫാക്ടോറിയൽ എന്നുള്ളൊരു ടേം മൈനസ് ചെയ്തു പോയിരുന്നുവെങ്കിൽ എന്ന് വിചാരിക്കുക. അതേപോലെ എസ് വണ്ടെ ഇക്വേഷന് എൽ വൺ എൻ വൺ ഫാക്ടോറിയൽ മൈനസ് ചെയ്തു പോയിരുന്നുവെങ്കിൽ എന്ന് വിചാരിക്കാം. അതുപോലെ ഈ ഒരു ടേമും മൈനസ് ചെയ്തു പോയിരുന്നുവെങ്കിൽ ഇതൊക്കെ ക്യാൻസൽ ആവുമായിരുന്നല്ലോ. ശരിയല്ലേ? അപ്പം നമുക്ക് കിട്ടുന്ന എക്സ്ട്രാ ടേംസ് ഇതൊക്കെയാണ്. ഒറിജിനൽ ഇക്വേഷനിൽ ഇതൊക്കെ ആദ്യമേ മൈനസ് ചെയ്ത് പോയിരുന്നുവെങ്കിൽ നമ്മളിങ്ങനെ ചിന്തിക്കുകയാണ്, പോയിരുന്നുവെങ്കിൽ എത്ര നന്നായിരുന്നു, നമുക്ക് 0 കിട്ടി. ശരിയല്ലേ? അപ്പം we are actually doing a ad hoc process. What we are going to do is we are subtracting an ad hoc term of k ln n factorial from original equation, from equation for entropy. ഇതൊരു ആഡ് ഹോക്ക് പ്രോസസ്സാണ്. അപ്പം ഗിബ്സ് പറഞ്ഞു യു ക്യാൻ റെക്ടിഫൈ ദിസ് ഇക്വേഷൻ ബൈ just subtracting an ad hoc k ln n factorial from our original equation. Now let us see this equation. This equation is what? You have nk ln v by h cube, our primary equation, plus 3 by 2 nk. Now you are decreasing, minusing an ad hoc term, right? Which is k ln n factorial. Ad hoc എന്ന് വെച്ചാൽ എന്താ? ആഡ് ഹോക്ക് എന്ന് വെച്ചാൽ റാൻഡം ആയിട്ടുള്ള ഒരു ടേം അങ്ങോട്ട് മൈനസ് ചെയ്ത് കളയുക എന്നുള്ളതാണ്. ഓക്കെ, അപ്പം then you can actually work on this, right? Do the mathematics, and you will eventually get our equation as 0 for reversible process. If you decrease an ad hoc term like this can be expanded according to Stirling formula. Stirling formula is given here. Then 3 by 2 nk becomes 5 by 2 nk, and there will be a minus nk ln, right? This can be taken out inside, right? So that you have nk ln v by n. This is our new term, right? So our equation for entropy is modified. Okay, now onwards, this is your equation for entropy for what? A free ideal gas system. Okay, this equation is very important as far as your net examination is concerned, as well as your Kannur University examinations are concerned. Okay, so I will just review this. First thing is, നമ്മൾ ആദ്യം പറഞ്ഞു, we actually made an equation for entropy. ഓക്കെ, അപ്പോൾ ആദ്യത്തെ കേസ് തന്നെ ഇറിവേഴ്സിബിൾ പ്രോസസ് ആണ്. ഇറിവേഴ്സിബിൾ പ്രോസസ്സിൽ യു ഹാവ് എ മിക്സിംഗ് ബിറ്റ്വീൻ ടു ഡിഫറെൻറ്റ് ഗ്യാസസ്, റൈറ്റ്? So with different number, uh, different number, different volume at same temperature. Mm. Now you find the uh, entropy of mixing. അതായത് ടോട്ടൽ സിസ്റ്റത്തിൻ്റെ entropy when wall is removed പണ്ടുണ്ടായിരുന്ന ഓരോരോ സിസ്റ്റത്തിൻ്റെ എൻട്രോപ്പി നമ്മൾ മൈനസ് ചെയ്ത് കഴിഞ്ഞാൽ യു വിൽ ഗെറ്റ് ചേഞ്ച് ഇൻ എൻട്രോപ്പി. ദാറ്റ് ചേഞ്ച് ഇൻ എൻട്രോപ്പി ഹാസ് ടു ബി പോസിറ്റീവ്, right? And that is according to our plans, right? According to second law of thermodynamics, our entropy change has to be positive, right? Now you are changing, you are changing to a different case where നിങ്ങളെ കയ്യിലുള്ള കമ്പാർട്ട്മെൻറ്റിൽ രണ്ടിലും ഒരേ ഗ്യാസ് ആണ്. In that case the process is no longer irreversible, but the process is reversible. ഓക്കെ, അപ്പോൾ അങ്ങനെയുള്ള ഗ്യാസ് സിസ്റ്റത്തിനെ എപ്പം വേണമെങ്കിലും നമുക്ക് പഴയ പോലെ ആക്കാം. സോ ദാറ്റ് മീൻസ് ദ എൻട്രോപ്പി ചേഞ്ച് ഹാസ് ടു ബി സീറോ. പക്ഷേ in our equation you are not getting zero, instead a positive quantity, right? That's where the paradox come. Now in order to solve the paradox, Gibbs suggested that if you can reduce an ad hoc term k ln n factorial from the original equation of entropy, then this problem will be solved. എങ്ങനെയാണ് സോൾവ് ചെയ്യുക? ബിക്കോസ് നമുക്ക് എൻട്രോപ്പി പോസിറ്റീവ് ആവുമെന്ന് പറയുമ്പം എനിക്ക് ഡെൽറ്റ എസ് കിട്ടിയിട്ടുണ്ടെങ്കിൽ കുറച്ച് ഇക്വേഷൻസാ കിട്ടുക. ആ ഇക്വേഷനിൽ എന്താ ഉള്ളത്? കെ എൽ എൻ എൻ ഫാക്ടോറിയലിൻ്റെ ഫോമുള്ള 3 ഇക്വേഷനാണ് കിട്ടുക. ഒന്ന് ടോട്ടൽ സിസ്റ്റത്തിൻ്റെയും ഒന്ന് ഇൻഡിവിജ്വൽ സിസ്റ്റത്തിൻ്റെ രണ്ടെണ്ണം, ശരിയല്ലേ? അപ്പോൾ നമ്മൾ വെറുതെ വിചാരിക്കുകയാണ്, ഇഫ് യു ക്യാൻ തിങ്ക് ദാറ്റ് ഇഫ് ഐ റെഡ്യൂസ് ദിസ് ടേം in the first place, in the first equation itself, അങ്ങനെയാണെങ്കിൽ ആ ടേം വരൂല. അപ്പോൾ ഓൾറെഡി മൈനസ് ചെയ്തുകൊണ്ട് ഈ ടേം ഒക്കെ ഓൾറെഡി പോവും. അപ്പം നമുക്ക് ഒരു പോസിറ്റീവ് ക്വാണ്ടിറ്റി കിട്ടേണ്ടതിന് പകരം യു വിൽ ഗെറ്റ് എൻട്രോപ്പി ഈസ് ഈക്വൽ ടു സീറോ. ഫ്രം ദിസ് ഇക്വേഷൻ യു വിൽ ഹാവ് ഡെൽറ്റ എസ് ഈക്വൽ ടു സീറോ for this equation. You can do the same process with this equation. You'll find that change in entropy will be equal to zero, because already we have reduced those terms in the first hand, right? So that's how Gibbs paradox is solved. Okay, now you can rewrite this equation and get a similar result, and that equation is called by a name which we will discuss now. You just rewrite this equation. You just isolate v by n. Then what remains is these two terms, right? You just take out v by n, and what remains is just this term, right? Um, this term. And you can also actually change this term by changing E is equal to 3 by 2 nkt. You just expand that, right? And after that you can take 5 by 2 inside, right? 5 by 2 inside. How can I take 5 by 2 inside? You just do this thing, right? This pretty simple. 3 by 2 will be here, so you have 3 by 2 here. If I take 3 by 2 from 5 by 2, what will be my result? 5 by 2. If I take 3 by 2 outside, right, then I have to put 2 by 3 here, right? 2 and 2 will get cancelled, and what you have 5 by 3, which is this one, and rest of the term. Okay, now this term is called Sackur tetrad equation. ഓക്കെ, അപ്പം എൻട്രോപ്പിയുടെ ഒരു പുതിയ ഇക്വേഷൻ നമ്മൾ കണ്ടെത്തി. ഓക്കെ, അപ്പം ഇഫ് യു വാണ്ട് ഐ ക്യാൻ സമ്മറൈസ് ദീസ് തിങ്സ് അഗെയിൻ. The thing is, you just got earlier you got um, earlier you got this equation for S, right? Now you are considering an irreversible process. You have two samples, two samples, two different samples, different. Mm. So the entropy of mixing will be irreversible. So you find the equation for S1, you find the equation for S2, and you find the equation for the total entropy of a system. Then you are going to calculate the change in entropy, which is this one. Now you consider a special case where small n is introduced, which is the number density. Why small n is introduced? Because here you have um, volume terms. You just need to change that into number terms. That's what we have done here. Okay, and you will find that the change in entropy has to be is a positive quantity here. So till now it's all pretty obvious. However, the paradox come when we are dealing with same gas sample. You are dealing with same gas sample. mm, then the process is no longer irreversible. The process is reversible process. In reversible process, delta S has to be 0, right? But in here, if we proceed the same way, just like irreversible process, the only change in this equation is instead of M1 and M2, you have M, because M1 and M2 is same, right? M1 equal to M2 equal to M, right? So there will not be any change in the equation. The equation is still positive instead of 0. Now you have to solve Gibbs paradox, which is stated here, right? Already. Now for that you do some mathematical gimmicks. You will change the equation of entropy into some factorial equation. Okay, so these factorial equations are just numbers, right? These are just numbers. Now if you think that if you can reduce those numbers in the first hand from the first hand equation, then ഇങ്ങനെ ഒരു ടേം വരാൻ കാരണം ഇത് ഒറിജിനൽ ഇക്വേഷൻ ഉണ്ടായോണ്ടാണല്ലോ. അപ്പോൾ ഒറിജിനൽ ഇക്വേഷനെ ഞാൻ ആ ടേം ആഡ്ഹോക്കായി മൈനസ് ചെയ്തിട്ടുണ്ടെങ്കിൽ ഇവഞ്ച്വലി ഐ വിൽ ഗെറ്റ് 0. ദാറ്റ്സ് ദ വേ ആക്ച്വലി ഗിബ്സ് പ്രൊസീഡഡ് വിത്ത്. ഓക്കെ, അപ്പം ഗിബ്സ് പറഞ്ഞു എസ് ഈസ് നോട്ട് this much, but you can reduce an ad hoc term from S, then everything will be okay. Okay, ഇനിയിപ്പോൾ ഈ ആഡ് ഓഫ് ടേം മൈനസ് ചെയ്തതിൻ്റെ ഇറിവേഴ്സിബിൾ പ്രോസസ്സിൽ ഒരു മാറ്റം വരില്ല. ഇക്വേഷൻ വിൽ ബി സെയിം ആസ് വാട്ട് യു ഗോട്ട് ഏർലിയർ. ശരിയല്ലേ? ഇവിടെ മാത്രമേ ഇക്വേഷന് മാറ്റം വരൂ. ദാറ്റ് യു ക്യാൻ ജസ്റ്റ് do an exercise and you can find it out. So that's how Gibbs paradox is solved. Now you can work on this equation and just rewrite it. Okay, and then you will get Sacker tetrode equation. So that is the story of Gibbs paradox and its solution.